This is chapter 5b, first order circuit. This chapter is aimed to introduce the step, response, RC and RL circuit. Explain the equation related for both circuits. Students should be able to determine the step response of both RC and RL circuit. In the previous chapter, you already been introduced with the source-free RC and RL circuit. So this is the step response RC and RL circuit. At the end, you should be able to differentiate in between the source-free RC and RL circuits with the step response RC and RL circuit. This topic will cover step response of an RC circuit and then step response of an RL circuit. So what is step response? Step response is the DC source exists in the circuit when the T is more than 0. And then the energy stored in the capacitors or inductor is released to R or charge. In the previous topic, source free, the DC source is not exist in the circuit when the T is more than 0. And then the energy stored in the capacitor or inductors only released to R and not being charged. In the step response, there will be an equations of the step response RL and RC. The equation will divide it into two types, which is initial values and the final value. This is the only value that is guaranteed to remain constant before and after the switch change. And you have to assume that the circuit has remained in the same state for a long time, leading up to times of switch change. And then you should remember when the switch is closed or open for a long time, what happened with the capacitor and inductor. So capacitor will be charging and then opens, and for the inductor will be charging until the maximum and then it will be short circuit. And then you have to compute VC or IL using simplified circuit at T equal to 0. So VC is for capacitor. You must remember that capacitor will be open circuits and there will be a voltage across the capacitor. And then if the circuit consists of L, the L will be short circuit, and then you have to find or identify the current that flow through the short circuits. So what is the final value? So assume that circuit has remained in the same state for a long time after switch change. Again, capacitor will be open and then the inductor will be short. And we have to compute the VC infinity or IL infinity using simplified circuit at T equal to infinity. So this is for capacitor and IL is for inductor. So RC circuit. Things to remember for a capacitor: if the V is constant or DC, I across terminal C is equal to 0 because of the C will be open circuit. So when the C here, we have a branch that consists of capacitor, and then when the capacitor is open circuit, so there is no current is flowing through the capacitor. And then the next will be we cannot change instantaneously across the capacitor. There is such a change would produce infinite voltage. This is the example of the circuit when T more than 0. Okay, if you remember previously, the conditions of circuits that you have to determines is, first is you have to determine when the t is less than 0, and then you have to find the V naughts of the capacitor. And then for the next step, because of source free, so there is no source in the circuit. Therefore, what you can do is you just find the tau, which is equal to, you just can find the tau, okay? But then for the step response, there will be another step, okay? So this is condition is for t is more than 0. So for the step response, there will be another step which is t less than 0, t more than 0, t equal to infinity. So there will be 3 stages, 3 circuits that you need to draw in order to determine the equations of the Vt. So this is one of the example. So if the circuits consists of current source, so this is a circuit that consists of the current source, and you can see that the switch is opens, and when the t equal to 0, it's closed. So t less than 0 is open, t more than 0 is closed. Okay, you can see that the existence of the source in the circuit compared with the previous topic, which is source free. And here is the V across the capacitor. Let's take a look at this circuit. So assume the IS is entering the nodes here, and then the currents is flow or exit the nodes for the IR, and then here is the current that's flow to the capacitor. So when you apply the KCL at this node, this is the KCLs of the node, and then you substitute the I for each of the elements by using the Ohm's law. But then for the capacitor is a bit different, which is this is the formulas of the currents that flow to the capacitor. And then actually you can refer to the textbooks either in a Sadiku or Nuisance, and the ends of the circuit equation will become like this one. This is the final equations of this circuit. So actually this equation is a bit complicated, so I will explain later in an easy way. So actually what you need to understand is there will be 3 types or 3 steps in order to understand the step response. So this is the general approach. So there will be the time, this is 0, t less than 0, and then t less than infinity. So there will be 3 conditions, which is t less than 0, t more than 0, t is infinity, or you can call this one as a t is equal to 0. So this one will be a value, this one will be equations of Vt, and then this is the value. Okay, so we call this one as initial, and here is the final. Okay, as you can see that this is final, initials, value, and it's also a value, and then the unknown will be here, unknown, the V the Vt. For example, when the T is equal to 0, you get 2 volt. And then when the T is infinity, you get 1 volt, for example. And then for the V, which is T more than 0, you get the tau, for example, 2 seconds. Okay, then you substitute the information into this equation, which is Vt is equal to V infinity plus V naught minus V infinity exponent minus T over tau. Just substitute the value, which is 1 plus 2 minus 1 exponent minus T over 2. So this is the answer of the question. This is the things or equation that you need to find, yeah, for this topic. Same as the source free, actually you can find the tau when the conditions of the circuit is T more than 0. Okay. So in this condition, the circuit will consist of voltage source, or current source. So you need to apply the concept of R Thevenins in order to find the R equivalence from the capacitor side, which is you need to terminate the voltage source by short circuits and then terminates the current source by open circuits, and then the circuit will left with only resistor, and then use the simplified techniques and find the R equivalence of the circuit, and then you have to substitute that equations into the tau equation, which is tau is equal to R Thevenins times with C. So the R Thevenins, or you can call it as the R equivalence, is the equivalent resistance across the capacitor terminal.